Okay, you know how the encoders work, have worked with a sample program that uses them, and observed their values in real time using the sensor debug window. Now all you need is some practice. Your robot should already have the Labyrinth using encoders program loaded, but if it doesn't, compile and download it to your robot. Place your robot behind the start line of the Labyrinth and run the program. Just a little too far. Let's go back to the program. Right now, our robot is moving forward for 1800 encoder counts. We know that one full revolution of the encoder is 360 counts, and the encoders are directly attached to the wheels. 1800 counts divided by 360 counts per rotation is equal to 5 rotations of the encoder and wheel. The robot needs to travel a shorter distance, so we'll need to pick a smaller encoder count. Remember, the robot is no longer being controlled by time or speed. Even slowing the robot down won't change the distance it travels. Let's try 1260 encoder counts, or 3.5 rotations. Compile and download. And run. Perfect. Now we need to program the robot to turn. We know how to turn and how to use the encoders, so it should be as simple as putting 2 and 2 together, right? Start by copying the code that makes up the forward for distance behavior, making sure to include the clear encoder commands, and paste them below. It probably won't take 3.5 rotations of the wheel to complete a 90-degree turn. So let's decrease the encoder count to an educated guess of 720, or 2 rotations. Now we want the robot to turn left, so make the left wheel go in reverse by setting the left motor to -63. That should do it. Compile and download and run. The robot moves forward, turns, and turns, and turns, and turns. Uh-oh, so much for this being simple. Maybe the sensor debug window can shed some light on our problem. Take the robot back to your computer and prop it up so the wheels aren't touching a surface. Compile and download the program to create a connection with the robot. Make sure the program debug window is set to continuously send updates, and the sensor debug window is open. And press the start button. The encoders count up while the robot moves forward, check. The encoder values are reset just before the robot turns, check. And the encoder values count. Hey, wait, what? No wonder the robot doesn't stop spinning. Our condition is set to have the robot turn until the value of the left encoder is greater than 720. But we have the left motor spinning in reverse, so the left encoder is counting in reverse. The encoder count will never be greater than 720, so it makes sense why the robot just keeps spinning. Let's correct this by switching which encoder the while loop's condition watches. Replace left encoder with right encoder to have the condition pay attention to the encoder spinning in the forward direction. Compile and download. And run. Much better. In this lesson, you learned how to modify the distance your robot travels, control its turns using the encoders, and use the sensor debug window to troubleshoot buggy behavior. Impressive, but don't stop now. Practice your newfound skills by completing the Labyrinth Challenge.